Hi class. So we are group 1 and we are going to present about the causes and characteristics of an earthquake. So let's go na sa basics. This our topics is just about a basic knowledge about the earthquake. So dito na tayo sa introduction to earthquake. An earthquake is a weak to violent shaking of the ground produced by the sudden movement of rock materials below Earth's surface. So gets nyo naman yan kasi um, meaning lang niyan yung paggalaw ng tectonic plates underneath the Earth's crust. Yun yung dahilan kung bakit nagkakaroon ng earthquake. And then very great earthquakes occur on average about once per year. Syempre hindi naman natin masyadong nararamdaman yung mga magnitude 5 or below minsan or depende pa rin sa building that we are in during that earthquake, 'di ba? Kasi may ibang earthquake na lalo na pag nasa high story ka talaga, mararamdaman mo yung paggalaw nung pag may lindol. So, next is over the centuries, they have been responsible for millions of death and incalculable amount of damage of properties. So, given naman yan kapag nagkalindol, marami talagang mamamatay since syempre hindi maayos or hindi stable yung building na ginagalawan mo or building na tinitirhan mo kaya most likely magko-collapse talaga tsaka matatrap kayo doon kaya marami talagang mamamatay. Tsaka pag hindi talaga pinag-aralan or inanalyze yung paggawa yung kung tama ba yung or stable ba yung um, ground na pagtatayuan mo ng building or ng mga infrastructures, then most likely ito yung mangyayari. Then causes of earthquakes. So, yung mga causes of earthquakes is una yung tectonic plates. Tectonic earthquakes. They are caused by the movement of tectonic plates. Yun nga, like what I have said earlier, yung paggalaw ng tectonic plates, nag-i-slip or nag-slide due to friction. Kunwari, yung mga tectonic plates kasi underneath the Earth's crust, they are always slowly moving. Kaso, they are stuck. So, stuck sila due to friction. But then, pag nakawala sila doon or pag nag-slide na talaga or pag nag-slip, yun yung nararamdaman natin na earthquake, na lindol, or na movement kapag nag-slip na, nagsisend sila ng parang energy waves sa epicenter or sa above the Earth's crust. So number 2 is induced earthquakes. These are caused by human activities like tunnel construction. Parang same lang to sa collapse earthquake since ito can be triggered by cave-ins or if they are close to mining facilities. Yung induced earthquakes kasi tsaka collapse earthquakes parang yung paggawa ng tunnel construction, syempre magdi-drill ka. E di syempre yung pressure na nararamdaman nun, meaning parang nadidisturb mo yung composition ng soil or components ng soil kaya kaya most likely nagiging loose yung soil kaya nagko-collapse. Kaya sabi ko same nga lang sila ng induced tsaka ng collapse earthquakes. And then kapag yun nga, nagsisink yung mga formation ng rocks kasi nadidisturb. Number 3, volcanic earthquakes. They are associated with active volcanism. Yun nga, yung pag-rise ng magma. Yung pag-rise ng magma, yun yung dahilan kung bakit nagko-cause ng earthquake yung sa mga, pag malapit ka sa vulkan, or yon. Tapos, or pag malapit ka sa mga active volcanoes. Tapos, etong picture is about the tectonic plates. Yun nga yung sinabi ko na sa inyo na ito yung mismong hypocenter. Hypocenter yung tawag nung, wait lang. Ito yung plates, ito, tsaka ito. And then yung hypocenter, ito yung tawag kapag nagmo-move, ito yung nagmo-move sa ilalim ng Earth's crust. And then epicenter na yung tawag kapag ito na yung nararamdaman natin. Yun na yung epicenter. Tapos yun. Next, yung world's deadliest earthquakes. Ito yung sa China ito yung pinakamalakas talaga hindi pinakamalakas. Pinakamaraming namatay dahil sa lindol dito. Sa China noong 1556, ang estimated na namatay or estimated death toll nila is around 830,000. And the magnitude is magnitude 8. So kasi based from what I've researched, maraming caves na ginagawa nun. So syempre magko-collapse talaga yun. Next is Haiti noong 2010. Ang death toll nila noon ay 316,000 and the magnitude is magnitude 7. So, yun yung naalala ko ito yung time na yung may sa We Are the World na charity song, yun. Tapos, yung sa Turkey noong 115. Tapos yun, ang death toll nila is around 260,000. Tapos, estimated lang yung mga sinasabi kong death toll though. Tapos, ang magnitude is magnitude 7.5. And after nung lindol dito is may tsunami na nangyari. Kaya around 260,000 yung namatay. Dito naman sa China, noong 1976, around ang estimated na namatay is 242,000 or 243,000. And yung magnitude is magnitude 7.5 din. So, dito sa Tangshan, China, estimated niya na 85% ng buildings collapse kasi hindi na built with proper knowledge or proper analyzation about the walang kinonsider na seismic waves or yung about sa earthquake. Hindi sila nag-consider nun kaya ang laki nung namatay na ang dami nung estimated na death toll dyan sa China. Then this one, Tokyo, Japan, noong 1923, ang estimated na death toll is 143,000 and ang magnitude niya ay magnitude 7.9. So 10% nung reinforced structures din dyan nag-collapse. Tapos after nun, nagkaroon din ng tsunami. So sobrang talamak talaga yung tsunami sa Japan, 'di ba? Ang tsunami niyan ay ang height ng tsunami nung dyan sa Japan noong 1923 ay umabot ng 12 meters. So sobrang taas. And then eto, yung mga responsibilities ng mga tao, responsibilities ng mga geologist, engineers, tsaka seismologist. Yung mga kailangan for to prevent or to have a stable or to avoid large death tolls sa earthquake. So unang-una ay yung sa geologist. As a geologist, they study map rock formations, collect rock samples and fossils, or measure the physical properties of Earth. So, yung mga ito a geologist is someone who works to understand the history of the planet we live on to better predict the future and explain current occurrences. So, yun. Hala, wait lang. Lobat na ako. Wait. Ayun. Sorry, nag-charge lang. Tapos, ayun, a geologist is someone who works to understand the history of the planet we live on to better predict the future and explain current occurrences. So, gets nyo naman yan na sila yung nag-aaral sa mga rock formations natin, sa mga para malaman kung stable na ba or matibay pag pag lalagyan mo ng infrastructures. And then they are also concerned with the changes of Earth over time such as climate change and land formation. Siyempre, hindi naman talaga consistent yung mga land formation tsaka yung climate change kaya yun talaga. Kaya hindi sila napapagod na pag-aralan or i-analyze yung mga ganitong bagay. Hold on. Tapos, yung fields in geology ay madaming fields kasi nung nag-research ako. Ito yung mga lumabas. Environmental geologist, engineering geologist, marine geologist, planetary geologist, economic geologist, petroleum geologist, etc. Tapos yun. So, ang kailangan kasi natin is yung engineering geologist kasi they assess whether the ground rock or yun nga yung sinabi ko kanina is stable or safe enough para paglagyan ng infrastructures. And then for seismologist responsibility, yung seismology kasi it is a study of natural seismic waves and related to hazards like earthquakes and volcanoes as well as their results like landslides and tsunamis. So yun, yung study nga ng seismic waves, energy waves caused by a rock suddenly breaking apart within the earth or the slipping of tectonic plates. Yun, tas ang ginagamit kasi ng mga seismologists parang more on software programs para mag-collect and analyze ng data. So yun. They also attempt to evaluate future risks and predict future destructive events. Their works help protect the people through preparation, advisories, and earthquake engineering. So yun nga, yun lang naman yung kailangan pag-aralan. Kailangan malaman kung stable ba talaga or pwede nang mag-build ng infrastructure on that certain area. And also a seismologist, they focuses or they figures how much time would an earthquake last and why they last for a certain amount of time. So yun. Ito naman ngayon is engineer responsibility. So buildings are made to withstand the force of gravity and the forces of their own structural design. The forces produced by earthquakes, particularly the side-to-side rolling motions, are completely different unless building is made to be flexible enough to bend with those forces or steady enough to withstand them. It will collapse in a strong earthquake, killing or trapping those that are within. So yung mga tayo, yung engineers, syempre, we must make strong structures. Yun nga na dapat mag-withstand ng ground motions of the earthquake. And also, as an engineer, we investigate the reasons why infrastructures and buildings fail during earthquakes para aral natin and may apply natin sa susunod na for planning. May apply natin yung knowledge na natutunan natin kung bakit nag-fail or nung nag-fail yung infrastructure or nag-fail yung structure nung nagkaroon ng earthquake para sa susunod na paggawa natin ng building hindi na ulit maulit ganon. So we must apply the knowledge to plan, design, construct, and manage earthquake-resistant structures and facilities. So, ayun. That's all. Yun lang yung topic ko for today. And before we proceed to the next reporter, may papanood akong video sa inyo and parang ito yung this sums up my whole report din, parang ganun. So, thank you.
Take a look at the outer surface of our planet. It may look like one solid shell. But according to the theory of plate tectonics, this outer layer, called the lithosphere, is actually broken up into massive, rigid slabs called tectonic plates that fit together like puzzle pieces. Floating on a thick, molten layer of the mantle called the asthenosphere, the plates slide around like slow-motion bumper cars, traveling up to 6 inches a year. Right now, Earth's crust is divided into 7 large plates and dozens of smaller ones. The boundaries between these plates are dynamic and violent places that make and break Earth's crust. The relative movement of the plates creates 3 types of boundaries. A divergent boundary occurs when 2 plates move away from each other. On land, you can easily see this. Diverging plates create huge troughs like the Great Rift Valley in Africa. If the spreading here continues, the Indian Ocean will eventually flood the rift, converting the entire eastern Horn of Africa into a massive island. Transform boundaries are where 2 plates grind past each other in opposite directions. The most famous example is the San Andreas Fault, where portions of Southern California, including Los Angeles, are sliding roughly 2 inches closer to Northern California each year. A convergent boundary, on the other hand, is where 2 plates collide. The impact often weakens and crumples the crust upward into jagged mountain ranges.
Yes, I'm Shelo Romar, the second reporter, and now we will tackle about the geological evaluation and the seismological evaluation. First, what comes into our mind when we say or when we hear the word geologist? Probably most of us tingin natin na they are all about rocks. Pero ano nga ba meaning ng geologist? Ano nga ba yung roles na ginagampanan nila when it comes to geological evaluation? Okay, let's define first the geologist. The geologist undertakes to determine the potentialities of earthquakes from the regional tectonics and the geologic structures. When we say regional tectonics, ito yung mga lugar na kung saan sakop ng earthquake. And the geologic structures naman, these features are formed in response to pushes and pulls associated with the forces that arise from the movement of tectonic plates or as a consequence of differential buoyancy between parts of the lithosphere. So yes, kung iisipin natin, malaki talaga yung role na ginagampanan ng mga geologists. Pero bukod sa dalawang nabanggit kanina, the geologist uses certain premises to infer the sources of earthquakes as well as, number 1, accepting volcanism. All earthquakes are caused by movement on faults. So lahat ng earthquake, except sa pagsabog ng bulkan, lahat yon dahil sa paggalaw sa ilalim ng lupa. Meron tayong iba't ibang uri ng fault na hindi natin siya i-discuss ngayon kasi hindi na siya sakop ng report ko. Number 2, whether or not a fault will produce earthquakes can be judged by the recency of fault movement. If a fault has moved recently, it will move again. Dito na papasok yung tinatawag nating aftershocks. And number 3, the sizes of a potential maximum earthquakes is in proportion to the size of the fault. So, nandun rin naman yung keyword. Number 4, a fault need not produce earthquakes of all magnitude levels. A fault commonly produces 1 or 2 sizes of large earthquakes that are characteristics for that fault. Number 5, geologic evidence should be corroborated with seismicity for interpreting potentials for earthquakes. Meaning, hindi lang dapat tayo nagbe-base sa lupa na na-form ng earthquake. Dapat may supporting evidence to gaya ng seismicity. Mamaya didiscuss natin kung ano ba yung seismicity. And their objective, number 1, to identify the sources areas for earthquakes. Kabilang dito yung fault, saan ba nanggaling yung earthquake, saan located yung focus niya, and ano yung naging cause niya. Number 2, to provide a rationale for assigning the maximum sizes for those earthquakes. Ito yung lugar na nakaramdam ng earthquake. And number 3, to indicate possible time framers for the recurrence of earthquakes. Possible aftershocks or earthquakes na pwedeng uling mangyari in the near future. So yes, after learning the geologists, hindi lang pala sila puro about rocks. And sa next naman natin i-discuss, seismological evaluation. The seismicity of a region provides the clues for identifying present-day tectonism. Their number 1 objective is to identify the sources of future earthquakes, thus corroborating the geologic evidence. Ito yung nabanggit din kanina natin. So, yung mga past earthquakes na nangyari sa isang lugar, nakakatulong siya para sa pag-identify ng future earthquakes. Doon kasi natin nakikita yung mga fault lines or fault areas. Meron ditong website kung saan pwedeng malaman natin yung mga active faults in our country. And it's called Hazard Hunter PH. Try natin. hazardhunter.ph. Yan, dito natin makikita hazard, yung seismic na lesson natin. Under non-active faults, fissures, EQ-induced landslide, liquefaction, and tsunami. Dito pwede rin natin makita yung earthquake monitor and volcano monitoring. Sa earthquake, nandito yung latest event na nangyaring earthquake. Ito yung Philippines. May earth. Dito natin may kita rin yung information for the date and time, location, magnitude, and yung lalim ng earth, ng fault. So, next naman natin. The seismic evidence may provide the following information. Number 1, attenuations of the earthquake motions from the source to the engineering site. Number 2, the spectral composition and the predominant period of the earthquake motions. And number 3, the range in the values for peak motions. Number 4, the rates of recurrence of earthquakes of given magnitudes. Yung meaning sa lahat ng data na magagather natin sa geological evaluation and seismological evaluation, pwedeng makatulong sa atin to sa pag-identify ng safe location na pagtatayuan ng mga future projects natin or mga structures.
Earthquakes are vibrations caused by rock breaking under stress. The rock breaks and moves along an underground surface called a fault plane. This movement is usually very sudden and releases a lot of energy, which is transmitted through the rocks as seismic waves. This event is measured on the moment magnitude scale. An increase of 1 unit of magnitude is equivalent to 10 times the amplitude and 30 times the energy. This means that a magnitude 2 earthquake will release 30 times the energy of a magnitude 1, and a magnitude 3 earthquake will release 900 times the energy than a magnitude 1. The point where an earthquake originates from underground is known as the focus. The location directly above this on the Earth's surface is known as the epicenter. Earthquakes create three different types of waves: P, S, and surface waves. The P waves, or primary waves, are compression waves. They're also known as push-pull waves. They travel the fastest and are the first waves to be detected. S waves, or secondary waves, are shear waves and move in a side-to-side motion. They're the second wave types to be detected. The last waves to be detected are surface waves that roll along the surface of the Earth. They are the most destructive waves as they make the ground move up and down, but they also lose their energy the fastest and cannot travel as far. The waves are detected and recorded using a seismometer to create a seismogram. Seismologists can determine how far away the earthquake struck by plotting the difference in the time of arrival between the P and S waves on a graph. Seismologists can determine the epicenter by drawing circles on a map, showing the radius of the distance from the earthquake of 3 or more seismic recording stations. The point where these circles intercept determines the epicenter of the earthquake. This method is known as triangulation. Earthquakes also tell us about the interior structure of the Earth. When there is an earthquake, there is an area between 103 to 142 degrees from the epicenter where no direct seismic waves are detected. However, beyond 142 degrees, P waves are again detected. Scientists have hypothesized that this is due to there being a liquid outer core, which the S waves cannot travel through, and that greatly slows down and refracts the P waves. Earthquakes also help to map out the tectonic plates that make up the Earth's crust. Earthquakes most frequently occur at plate boundaries. By plotting the location of earthquakes over the past month, the outline of the plates becomes clear. However, not all earthquakes happen at plate boundaries. Sometimes there are intraplate earthquakes that occur because of stresses in rocks being released. This is what caused the 1968 Meckering earthquake in Western Australia, which had a magnitude of 6.5 and caused major damage to structures and infrastructure, including roads and railway lines, and injured about 30 people. Scientists are researching ways to predict when an earthquake might happen, such as sampling gases released from underground and measuring built-up stresses in rocks. However, there is currently no way to know for certain where and when the next one will occur and how big it will be.
Engineering evaluation. The engineering undertakes the evaluation of earthquake hazards to structures by making use of two general types of analysis, the pseudostatic and dynamic analysis. Pseudostatic analysis investigates the dynamic earthquake loading by replacing the dynamic effect with the force that is applied statically to a structure or a structural component at the center of mass. So, yung pseudostatic approach ay isa sa mga simpleng methods for idealizing slopes na subjected to earthquake force. Magagamit din tong method na to para i-evaluate yung performance ng mga constructed embankment ng soils such as clays, clay soils, dry or moist cohesionless soils, and dense cohesionless soils kung saan hindi nababawasan yung significant strength during earthquake. Sa earthquake-prone areas, ginagamit yung vertical pseudostatic coefficients K sub H and K sub V para makompute yung horizontal and vertical forces caused by an earthquake. So, ito yung formula. Horizontal or vertical force is equal to acceleration times weight over gravitational acceleration or simply pseudostatic coefficient times weight. K is dimensionless coefficient or the ratio of acceleration and gravity. K sub H coefficient of acceleration in horizontal and K sub V coefficient of acceleration in vertical. For pseudostatic coefficient, it can be positive or negative. Pag positive yung coefficient, ibig sabihin, yung earthquake is acting downward in the direction of gravity. Kung negative naman, yung earthquake force is acting upward against gravity. Saan nga ba kinukuha yung pseudostatic or seismic coefficient? Coefficients have to be determined for each type of structure whether it is a bridge, a building, an earth dam, or any other structure. To obtain a seismic coefficient, one generally has a available map that can be for anything from a continent to a city and may be contoured or zoned to provide appropriate coefficient location.
So the second type of analysis in engineering evaluation is the dynamic analysis. A dynamic analysis tests a structure by applying a cyclical load approximating that of an earthquake as it would be felt at an engineering site. So yung cyclical load is from cyclic loading, which is the application of repeated or fluctuating stresses, strains, or stress intensities to locations on structural components. So kinokonduct yung dynamic analysis to obtain either a linear or nonlinear structural response. Also, if your application involves significant accelerating or decelerating motion, inertial forces will be present and a dynamic analysis is required to capture their effects. Dynamic analysis can accurately capture resonant behaviors when it is experienced. So we have two general approaches used to specify earthquake motions. We have the non-site specific and the site specific. The non-site specific assignment of motions does not require a geological seismological evaluation for the site. Peak values for acceleration and for velocity are taken from maps prepared for this purpose. So yung peak values ay yung maximum values attained by an alternating quantity during one cycle, yung cycle sa cyclic loading. So these maps are made with a specified level of probability calculated into the motions. So the applicability and dependability ng mga maps na yon must be judged on an individual basis. These peak motions are then entered into standard diagrams for smooth response spectra. The peak motions can be modified by factors for site condition, grade of structure, and so on. So marami siyang factors. The non-site specific approach is best for expedient analysis of elastic structures. So mas best siya kapag elastic or linear structures, but it can be used also for the evaluation of ductility in the designs. So next is the site-specific. A site-specific evaluation begins with the geological seismological evaluation of earthquake sources. So unlike nung non-site specific, itong site-specific, it begins with the geological seismological evaluation and is carried up to a specification of time history or time histories that will be appropriate for the engineering site. These are expressed as free field motions at the ground surface for either soil or rock. So free field motions is the motion that occurs in the soil or rock layers at some depth from the ground surface in the absence of any structure or excavation. So the site-specific approach is especially useful when nonlinear effects are important. So oppositely no non-site-specific na best kapag linear or elastic, ito namang site-specific, it is best kapag importante yung non-linear or inelastic effects. So, however, the approach can be used for any category of analysis. So, the interpreted earthquake ground shaking may be applied to a structure by any of various methods. So, the consequences of failure. So, perceived consequences of failure is an important factor if an earthquake occur. So, meron tayong two cases. The first case is if a failure presents no hazard to life, and if there is a cost-risk benefit from a lesser design, an owner may be willing to accept this risk and construct accordingly. So, next case naman, if the consequences of failure are intolerable or unbearable, malala, example dito as in the failure of a dam above an urbanized area, Then the most conservative and defensive design is called for. So, yon. So, that's all for the basics. Thank you for listening.
The ground starts to quiver, glasses rattle. Soon, walls shift and everything begins to collapse. Telltale signs of what could be a devastating earthquake. We've seen the destruction they unleash. Some of us may have even lived through one. And we know they can be deadly. But where does this mountain-moving force come from? While we may think we're standing on solid ground, the Earth beneath us isn't completely stable at all. Our planet's crust is made up of about 12 major tectonic plates that fit together like a giant jigsaw puzzle. These huge slabs of land float on superheated magma and constantly shift, bump, and grind against one another. It's there, along the seams, where earthquakes tend to happen. When friction between the two plates is violent enough, seismic shockwaves ripple through the ground, rattling everything that stands on it. The stronger and shallower the quake, the more violent the destruction. The most violent type of earthquake is born in a subduction zone, where one tectonic plate is shoved beneath another. While one plate is forced downward into the mantle, the other juts upward, often violently. This is the type of quake that rocked Nepal in May 2015. And when subduction happens under the ocean, it can create giant, unstoppable waves called tsunamis, like the ones that killed hundreds of thousands in Japan and Indonesia. On average, earthquakes kill about 10,000 people each year. Sometimes numbers are far higher. The quake that hit Haiti in 2010 killed more than 300,000 by some counts, making it one of the deadliest on record. It is estimated that there are 500,000 detectable earthquakes in the world each year. 100,000 of these can be felt, and 100 of them cause damage. That's about 0.1%. The magnitude of an earthquake is measured using the Richter scale, which runs from 0 to 10, 10 being the strongest. Every whole number increase on the scale means 10 times more ground motion change. In recorded history, the world has never experienced a 10 on the Richter scale, but scientists predict an average of at least one major quake of magnitude 8 or higher every year. The fact is, the Earth's crust is restless and always on the move. We can't see earthquakes coming, but we can prepare for them. Engineers are now designing stronger buildings, resilient enough to survive a direct hit. Scientists are crunching data to project the power of future quakes and anticipate when and where they could strike next. Right now, we can only estimate the probability an earthquake will occur, but perhaps one day we will learn to predict them, minimizing their destruction and saving countless lives.
Se cayeron edificios. Se cayeron edificios.
Este edificio se movió horrible, horrible. Tronó horrible. Que se salgan, la pared se rompió. Que se salgan. Que se salgan, se va a caer. Se va a caer. Dios mío, Dios mío, Dios mío, Dios mío. Dios mío, Dios mío, Dios mío, Dios mío.
No mames, está cabrón, güey. ¿Qué pedo? Pues eso está muy cabrón, güey.
No.
Mírame la cantidad de edificios que se cayeron. No lo puedo creer.
No, impresionante.
Pues yo vi uno cayéndose aquí, güey, ahí al ladito. No puede ser.
Don't let yourself be convinced to do something that you know is bad, and then Ian finally just shared with us. Cover your mouth with your shirt. Everybody okay?